So we have discussed all the concepts that are important for exercise 1D. So let us start exercise 1D. So the question is, find the condition that the tangents drawn from 0, 0 to S be perpendicular to each other. For example, this is a circle. So from an external point P, two tangents are drawn. So let us suppose that the tangents meets the circle or touches the circle at A and B. So this is a radius. This is perpendicular and this is also perpendicular, as we all know that. So if theta is the angle between the tangents, drawn from P x1 y1 to the circle S is equals to 0, then tan theta by 2. So this is whole theta and this is theta by 2 and this is also theta by 2 that we have seen in the theorem. So tan theta by 2 is equals to R by root S11, where R is the radius of the circle and root S11 is the length of the tangent drawn from the point P to the circle. So this is root S11, this is also root S11. So here the condition given is this theta is 90 degrees, because the condition that the two tangents to be perpendicular to each other. That means this is 90 degrees. If this is 90 degrees, then what is the condition? So given that theta is equals to 90 degrees, so radius R is equals to square root of G square plus F square minus C and root S11. What is root S11? The length of the tangent drawn from P x1 y1 to the circle. So since this is a general equation of a circle, so root S11 is square root of x1 square plus y1 square plus 2g x1 plus 2f y1 plus c. So the given point P x1 y1 is 0, 0. So substitute root S11 is equals to square root of 0 square plus 0 square 2g into 0 2f into 0 plus c. So under root, therefore root S11 is equals to root c. Okay, so now tan theta value is 90 degrees. 90 degrees by 2 is 45 degrees is equals to R value is square root of G square plus F square minus C by root S11 means root C. So tan 45 value is 1 equals to square root of G square plus F square minus C by root C. So if you cross multiply, root C is equals to square root of G square plus F square minus C. So squaring on both sides, C is equals to G square plus F square minus C. Therefore G square plus F square is equals to this minus C, if you bring here, 2C. So this is the condition for the two tangents to be perpendicular to each other. Now the second question is, find the chord of contact of 0, 5 with respect to circle is given. So let us suppose that this is a circle S equals to 0. This is P x1 y1 is a external point. What is the chord of contact? The line joining from The second question is, find the chord of contact of 0, 5 with respect to circle. So what is the chord of contact? The line joining of the points of contacts of the tangents drawn from external point P with respect to circle S is called the chord of contact. That means from P external point, if we draw two tangents, then A is the point of contact of this tangent to the circle. Here B is the point of contact. So these two point of contacts, if we join, this is called the chord of contact. Chord of contact. Okay, so this line is called the chord of contact. So the equation of the chord of contact is equals to contact of P x1 y1 with respect to circle S is equals to 0 is S1 equals to 0, implies P x1 y1 is given P x1 y1 is equals to 0, 5 and circle S is x square plus y square plus minus 5x plus 4y minus 2 equals to 0. So its S1 is x1 plus y1, the same sign with the half of the x coefficient. So 5 by 2 into x plus x1 plus same sign with half of the y quotient, 4 divided by 2. So 2 into y plus y1, okay, plus minus 2 is equals to 0. That is equals to x1. So x into 0, 0 plus y into y1 value is 5. So 5y minus 5 by 2 into x plus x1 value is 0 plus 2 into y plus the value of y1 is 5 minus 2 equals to 0. So that is equals to 2 is the LCM, 2 5s are 10y minus 5 into x 5x plus 2 is the LCM. So 2 2s are 4 into y 4y, 4 5s are 20 minus 2 2s are 4 is equals to 0. So minus 5x 10y plus 4y 14y 20 minus 4 plus 16 equals to 0. Therefore 5x minus 14y minus 16 equals to 0. The third question is same. Find the chord of contact of 1, 1 with respect to x square plus y square equals to 9. Earlier one is general equation of a circle and this one is a standard equation of the circle whose center is at the origin. Solution. So let S is x square plus y square minus 9 equals to 0. P x1 y1 is 1, 1. So the equation of the chord of contact of P x1 y1 with respect to circle S is equals to 0 is S1 equals to 0, implies the S1 for this is xx1 plus y1 minus 9 equals to 0. So x1 y1 being 1 and 1. So x into 1 x plus y minus 9 equals to 0. The next question is find the polar of 1, 2 with respect to circle x square is plus y square equals to 7. So what is the polar? The locus of the point of intersection of the tangents drawn from an external point lies on a line called, this is a polar and this is a pole. So number of the next question is, find the polar of P with respect to circle. What is the polar? We have already discussed. Again I am telling you. So the locus of the point of intersection of the tangents drawn at the extremities of the chord. So for example, from P, this is a secant line and this being a chord. From the extremities of this chord, I have drawn a tangent. From this extremities of the same chord, I have drawn another tangent. So let us suppose that they are meeting at this point Q. In the same way, from this external point, one secant line I have drawn. Earlier one is, for example, AB is one chord and this time CD is another chord. So from an external point P, I have drawn a secant line and CD being the chord. So C comma D are the extremities or the endpoints of this chord. So I have drawn a tangent through C. I have a tangent drawn through the another extremity of the chord, which is D. So these two tangents drawn meet at this point, for example R. Then the locus of these points. So if you join all these points, so because actually I have drawn two secants, so n number of secants we can draw. So since these are two chords, therefore two points are happened here. So n number of chords can be drawn, secants can be drawn. Therefore n number of points we are getting. So all are lying on this line. This line is called the polar of this point P. So the solution, so the equation of the polar of P with respect to circle S is equals to 0 is again S1 equals to 0. S1 equals to 0. The equation of the chord of contact is also S1 equals to 0. So the last third problem we have discussed. And before that, in the second exercise also, the equation of the tangent is also S1 equals to 0. Therefore, equation of the tangent, equation of the chord of contact, equation of the polar, for all this S1 equals to 0. But the point is different. As far as tangent is concerned, for example, the point is this. The point is this. Px1 by 1. So S1 is equals to 0. But this time point P is here. So now given that Px1 comma y1 is equals to 1 comma 2 and S is x square plus y square equals to 7. So S1 is equals to 0 implies xx1 plus y1 minus 7 equals to 0. So x into 1 x plus y into 2 2y minus 7 equals to 0. The same type of question again, find the polar of 3 comma minus 1. But this time this is not a general equation. So or a standard equation. What is the standard equation of a circle? X square plus y square equals to r square. The quotient of x square and y square is 1. But here 2. So first let us try to convert this into the standard equation. Given circle equation is S 2x square plus 2y square minus 11 equals to 0. That implies S is equals to x square plus y square minus 11 by 2 equals to 0. So S1 equals to 0. Equation of polar is S1 is equals to 0. Equation of polar of P x1 y1 with respect to S is equals to 0 is S1 equals to 0 implies x x1 plus y y1 minus 11 by 2 equals to 0 implies x1 is 3. So 3x y into minus 1 minus y minus 11 by 2 equals to 0 implies, therefore 2 3s are 6x minus 2y minus 11 by 2 is equals to 0. 2 if you transpose that side is equals to 0. This time general equation is given. So the equation of the polar, so P x1 y1 is equals to 1 comma minus 2. So S is x square plus y square minus 10x minus 10y plus 25 equals to 0. So we should be very familiar of writing S1 equals to 0. How do we write S1? I am telling you again. S1 is x square is x1 plus y square is y1. So remain the same sign. So quotient of x is 10, it's half. So 5 into x plus x1. So minus remains same. The quotient of y is 10, half of that. So 5 into y plus y1 plus 25 equals to 0. So that is equals to x1 y1 point is 1 comma minus 2. So x into 1 x plus y into minus 2 minus 2y minus 5 into x plus x1 x plus 1 minus 5 into y plus y1 y plus minus 2 that is minus 2 plus 25 equals to 0 implies x minus 2y minus 5x minus 5 minus 5y minus into minus plus 5 2s are 10 plus 25 equals to 0. That implies x minus 5x minus 4x minus 2y minus 5y minus 7y 10 plus 25 35 minus 5 plus 30 equals to 0. Therefore, if you cancel minus throughout the equation, then 4x plus 7y minus 30 equals to 0. So the next question is, find the pole of ax plus by plus c equals to 0 with respect to circle. Earlier question, find the polar of this point P. The line ax plus by plus c equals to 0 we used to get ultimately, right? Now find the polar of, this time last problem, the point P with respect to circle S is equals to 0 is given. So for this point P, the line equation we found, that is the polar equation of this point P. This time the line is given and we are asked to find the pole P of this polar. This time we are required to find out the point P x1 y1. Earlier we found the equation of the polar ax plus by plus c equals to 0, which is a straight line. Polar is a straight line, pole is a point. So we knew the formula, the pole of the line Lx plus my plus n equals to 0 with respect to circle x square plus y square equals to r square is minus L r square by n minus m r square by n. So here L and m values are a and b. So this is equals to minus a r square by, so n value is c, a r square by c minus b r square by c. So the same pole of the line Lx plus my plus n equals to 0 with respect to general equation of a circle, minus g plus LR square by LG plus MF minus N and minus F plus MR square by LG plus MF minus N. This is for general equation of the circle S, x square plus y square plus 2gx plus 2fy plus c equals to 0. For example, we don't know this formula. So what is to be done? Let us see. So that is let P x1 y1 be the pole of ax plus by plus c equals to 0. So this straight line is there. This straight line is ax plus by plus c equals to 0. For this straight line ax plus by plus c equals to 0, so we have to find the pole P. So for which I have taken this P to be x1 y1. So the equation of polar of P x1 y1 with respect to circle S is equals to 0 is S1 equals to 0. Implies what is S1? X1 plus y1 minus r square equals to 0. So let us suppose that this is the first equation. So what is this x1 plus y1 minus r square equals to 0? This is the polar of P with respect to circle. That means this line. This is this line. According to the question, the same line is ax plus by plus c equals to 0. But so the line is given line is ax plus by plus c equals to 0. So 1 and 2 represents the same lines. 1 and 2 represent same lines because for this point P x1 y1, S1 is equals to 0 means this line. So according to the question, that line represents ax plus b, the same line represents ax plus by plus c equals to 0. So these two represents the same lines. Whenever the lines are same, we can compare the coefficients. So comparing we get here x quotient is x1 by here x quotient is a is equals to y quotient is y1, here y quotient is b is equals to constant is c. So x1 by a is equals to minus r square by c implies x1 is equals to minus a r square by c. Likewise, similarly, and y1 by b equals to minus r square by c. That implies y1 is equals to minus b r square by c. Therefore, the pole P x1 y1 is minus a r square by c comma minus b r square by c. This point you may check with the actual formula. Initially we have applied the formula where we got the same answer, minus a r square by c minus b r square by c. The next question is, find the pole of 3x plus 4y minus 45 equals to 0 with respect to the circle. So in the last problem we have discussed, so the pole of the line Lx plus my plus n equals to 0 with respect to circle S, general equation of the circle x square plus y square plus 2gx plus 2fy plus c equals to 0. Last problem it is x square plus y square equals to r square, which is a standard form of the circle. The formula is minus lr square by n minus mr square by n. So for this, the pole is P is equals to minus g plus lr square by lg plus mf minus n minus f plus mr square by minus f plus mr square by lg plus mf minus n. So here g value is, if you compare this with the general equation of a circle, x square plus y square plus 2gx, 2g is equals to minus 6, g is equals to minus 3. 2fy, 2f equals to minus 8, f equals to minus 4, and c value is 5. So then radius is equals to square root of g square plus f square minus c, square root of 3 square 9, 4 square 16, minus 5. So how much? This is 9 plus 16, 25 minus 5. So root 20. So r is equals to root 20. Therefore r square equals to root 20 whole square is 20. So here Lx plus my plus n equals to 0 is to be compared with this. So the quotient of L is equals to 3, m is equals to 4, n is equals to minus 45. So everything we have under the denominator also we will find once. Lg plus mf minus n is equals to Lg. So 3 into minus 3 minus 9. Mf 4 into minus 4 minus 16 minus n. N value is here, n value is minus 45, right? So minus of minus plus 45. So this is equals to, this is minus 25 plus 45. So this is 20. So this value, now P is equals to, what is minus g? Minus of minus plus 3 plus LR square. L is 3 into R square is 20. 3 20 60 by, what is Lg plus mf minus n? 20, comma minus f. So minus of minus, so plus 4 plus mr square. M is 4, r square is 24, 20 is 80 by 20. So this is 4 times 23 60. 3 plus 3 6, comma 4 plus 4 8. This same thing we can do in another way also, which will be explained after this. Let us see another alternative of the problem that we have discussed before. Using formula we have arrived to the answer 6, 8. So let us see, without applying the formula also can we get this 6, 8. So let Px1 y1 be the pole. Okay, so the equation of polar of P x1 y1 with respect to s is equals to 0 is s1 equals to 0. Let Px1 y will be the pole I have taken. So if this is a pole, the polar of this is this. So that is s1 equals to 0. So s1 is xx1 plus yy1 minus 3 into x plus x1 minus 4 into y plus y1 plus 5 equals to 0. So this implies This is x1 minus 3x. If you take x as a common, x1 minus 3. Since this is a polar represents a straight line. Straight line is of the form ax plus by plus c equals to 0. First degree equation. So x, y and constant. So x, next y I will write and then constant. So y1 minus 4y. If you take y as a common, y1 minus 4. So I am left with minus 3x1 minus 4y1 plus 5 equals to 0. So this can also be written as x into x1 minus 3 plus y into y1 minus 4. If you take minus as a common, 3x1 plus 4y1 minus 5 equals to 0. Okay, and so let us suppose that this is first line. So given line is 3x plus 4y minus 45 equals to 0. This 3x plus 4y minus 45 equals to 0 is this line. So this line's pole is what we are required to find. So then according to the question, this line is 3x plus 4y minus 45 equals to 0. According to theory, if px1 y1 is the pole, then this is the polar. That means 1 and 2 represents the same straight lines. 1 and 2 represents same lines. That implies the quotient of x is x1 minus 3 by 3. The quotient of y, y1 minus 4 by 4 is equals to minus of, this is constant, 3x1 plus 4y1 minus 5 by minus 45. So minus gets cancelled, implies x1 minus 3 by 3 is equals to 3x1 plus 4y1 minus 5 by 45. So 45 into x1, 45x1, 45 3s 135. Next 3 3s 9x1, 3 4s 12y1. Next 3 5s 15. So this is equals to 45x1 minus 9x1, 36x1. This is plus 12y1. If you bring here minus 12y1 minus 135 plus 15. So 5 minus 5 0, 3 minus 1, so 120 equals to 0. If you cancel 4 table, okay, then this is 12 table. If you cancel, 12 3s are 36, 12 1s are 12, so y1, so plus 10 equals to 0. This is the first equation. So this and this also if you equate, then another equation of the line of this kind we will be getting. So solving 1 and that 2, then the same 6, 8 answer we are going. So 135 plus 15 is 120. So if I cancel 12 table, then minus 10 we are getting. So I have wrongly I have written plus there. Okay. Okay. Now see this 45y1, 45 4s 180 is equals to 4 3s are 12x1, 4 4s are 16y1 and 4 5s are 20. This is equals to 12x1, 16y1 minus 45y1 minus 29y1. So 4 3s are 12x1. So 29, 16 minus 45y1 is minus 29y1. So this minus 180 if you bring to that side, so plus 160 equals to 0. Let us suppose that this is the second equation. Now solving 1 and 2. So first equation I'll multiply with 4. Then 4 3s are 12x1, 4y1, 4 10s are 40 is equals to 0. And second equation is 12x1 minus 29y1 plus 160 equals to 0. So I am subtracting minus plus minus. So 12x1 gets cancelled, plus 29y1 minus 4y1 plus 25y1 minus 160 minus 40 minus 200, that is equals to plus 200. So therefore y1 equals to 200 by 25 eighths. So substituting y1 in whichever the equation you want, no problem. So first equation I will substitute. So 3x1 minus y1 is minus 8 minus 10 equals to 0. So 3x1 minus 18 minus 10 minus 18, if you take that side, plus 18. Therefore x1 is equals to 18 by 3, which is 6. Therefore x1 comma y1 value is equals to 6 comma 8. 6 comma 8. So you may check this with the formula based solution as well. See, I did not rub this. So 6 comma 8 is what we have got earlier. So that and this can be compared. The next question is, show that the points are conjugate points with respect to circle. So what are conjugate points? Two points are said to be conjugate points if 2 points P comma Q are said to be conjugate points if the polar of P passes through Q and the polar of Q passes through P, then P comma Q are said to be conjugate points. And we have a direct condition as well. So the condition that the points P x1 y1 comma Q x2 y2 to be conjugate with respect to circle S is equals to 0 is S12 equals to 0. So x1 y1 is this and x2 y2 is this. Given points are x1 y1 is equals to minus 6 comma 1 and x2 y2 is equals to 2 comma 3. So S12 equals to 0 implies x1 x2 plus y1 y2 minus of x1 plus x2 plus y1 plus y2, the quotient of 2 is 1 into y1 plus y2 plus 1 equals to 0. So he is asking to show that these 2 points are conjugate points. That means this value yields 0. So I am not taking 0. So we need to get 0. If we are getting this 0, then yes, we can say that the 2 points are conjugate points, for which substitute x1 x2 minus 6 2s are minus 12, y1 y2 1 into 3 3 minus x1 plus x2 minus 6 plus 2 minus 6 plus 2 minus 4 plus y1 plus y2 1 plus 3 4 plus 1. That implies minus 12 plus 3 plus 4 plus 4 plus 1. So 4 plus 4 9, 4 plus 4 8 plus 1 9 plus 3 12, 12 minus 12, yes, 0 we get. Therefore the given points are conjugate points. Now the next question is find the value of k if the two lines are conjugate with respect to circle. So earlier question is two points are conjugate if the polar of this point is passing through Q and the polar of this point Q is passing through P. Then these points are said to be conjugate points. Now this time two lines L1 equals to 0, L2 equals to 0 are given. Two lines are said to be conjugate lines if the pole of this line L1 equals to 0 lies on L2 equals to 0 and the pole of this line L2 equals to 0 lies on L1 equals to 0. Then these two lines are said to be conjugate lines. So we have the condition that the lines L1x plus M1y plus N1 equals to 0 and L2x plus M2y plus N2 equals to 0 with respect to circle S is equals to 0 to be conjugate lines is R square into L1 L2 plus M1 M2 is equals to M1 L2 for the standard equation of the circle x square plus y square equals to R square. But since this is a general equation of a circle, this is L1G plus M1F minus N1 into L2G plus M2F minus N2. Now, so L1 x plus M1y plus N1 equals to 0. L1 is equals to k. L2x plus M2y plus N2 equals to 0. L2 is equals to 2. Next, M1 3, M2 1, quotient of y. N1 minus 1, N2 5. So, and G is equals to, so 2gx, 2g equals to minus 2, g equals to minus 1. 2f is equals to minus 4. So this could be compared with the general equation of a line, circle. F equals to minus 2 and c is equals to minus 4. So from this radius r equals to square root of g square plus f square minus c square root of g square 1 square 1, 2 square 4, c is minus of minus plus 4. So root 9 which is 3. So now substitute r square 3 square 9 into L1 L2. So 2k plus M1 M2 3 ones are 3 is equals to L1G. So k into minus 1 minus k. So plus M1F 3 into minus 2 minus 6 minus N1 plus 1 minus of minus into L2G 2 into minus 1 minus 2, m2f 1 into minus 2 minus 2 minus n2 minus 5. So this is equals to 9 into 2k plus 3 is equals to, this is minus k minus 5. This is minus 2 minus 4 minus 5. So totally this is minus 9. So this is equals to 9 into 2k plus 3 is equals to, take minus as a common. So k plus 5 into, this is minus 9. Minus minus gets cancelled. 9 ones are 9. So 2k plus 3 is equals to k plus 5. So 2k, this plus k if you take this here, k is equals to, so this is 5, this plus 3 if you take to that side, k is equals to 2. The next question is, find the value of k if the points are conjugate. That means the points are conjugate is already given. So what is the condition for the 2 points to be conjugate with respect to circle S is equals to 0? S12 equals to 0. So is equals to 0 because conjugate na S12 equals to 0 we will take. In that course we will be getting k. So the condition for the 2 points to be conjugate with respect to circle S is equals to 0 is S12 equals to 0, implies x1 x2 plus y1 y2 minus 35 equals to 0. So since the points are conjugate, they have to satisfy the above condition. Satisfying in the sense substituting the given values. So x1 x2 1 into 2 plus y1 y2 3 into k 3k minus 35 equals to 0. 3k 2 minus 35 minus 33 equals to 0. 3k is equals to 33. Therefore k is equals to 33 by 3 11.